here because we didn't get to this in fifth period. But this next problem is going to be a little different animal. What's different about this problem? When we solve for x or y, we're going to end up getting fractions.
Oh my gosh.
Yeah. There's just really no way around it. You're just going to get fractions on this, and we're going to work with the fractions. This goes from really easy, the first two examples, a little bit complicated with the first example on this page, and then letter B is a really complicated problem. It would trick up some Algebra 2 students because of the fractions that are involved, but we're going to look at it and see what we get. We need to pick an equation, like the steps of the process says. Pick one of these equations and solve for one of the variables. Which one do you want to use?
The first one.
The second one.
I already did the top one. So
Yeah, I already did the second one.
All right, what did you do?
I did the second one. I solved for x.
I solved for y.
You solved the bottom equation for x? Let's do that. That's what I would have done, because it's going to give you a 2 as a denominator instead of a 4 or a 7 or a 3. You know, and the smaller denominators, maybe it's going to be easier to eliminate and work with, because we're eventually going to eliminate the fractions, right? Because we can do that. If we solve this for x, we get 2x equals 3y minus 11, which means x equals 3 over 2y minus 11 over 2. All right, that's what x is equal to. So I'm going to take that and I'm going to substitute that value for x into the other equation in the place of x. So I will get 4 times 3 halves y minus 11 halves. Oh, this is going to work really nicely. Equals 43. Okay, because when we multiply those fractions by 4, what's going to happen to the fractions?
They're going to be gone.
They're going to be gone, right? 4 times 3 halves is 6. 4 times negative 11 halves is negative 22. Plus 7y equals 43. We're going to add the 6y and the 7y and add 22 to both sides. We're going to get 13y equals 65. And that means that y is equal to, which is 5. Yeah, y equals 5. Now we'll put that into one of our original equations. Really, any equation anywhere will work. But let's pick this one right here. Let's just 2x minus 3 times y equals negative 11. If I add 5 to both sides, add 15 to both sides. Is that right? I get 2x equals 4, which means x equals 2. So it appears that my solution is 2, 5. We're going to check that in the other equation that we didn't use to get x equals 2. Is 4 times 2, 8, plus 7 times 5, 35, equal to 43. It is. So 2, 5 is what? It's the solution to the system of equations, which means it is the point of intersection. Now, the strategy here, guys, if you're having to work with fractions, choose the smallest denominator possible. If you had solved the first equation for either of those variables and made substitutions, you're not going to end up getting fractions that disappear. You're going to make it more complicated on yourself. All right? But if you do end up with an equation that has fractions, what are you going to do? Multiply through the equation to get rid of fractions after you make your substitution and distribute. Okay? All right, last one. A school play charged $8 for adults, $5 for students. There were 75 people who attended the play. The box office collected $444. How many adults and how many students attended the play? And this says use substitution to solve. So we're having to write a system of equations and use substitutions to solve. So what are the two systems of equations we'll use? Adults.
Wait.
8. You want students to be X. Excuse me for yawning. Or excuse me, adults to be X and students to be Y. Okay. So then 8X plus 5Y equals $444. All right. Now, what's the other equation that we could use?
75.
X plus Y equals 75. Right? Yeah, it's really not that bad. And then we need to solve one of these for X or Y, which really makes the second one the candidate, right? Solve for Y. Y equals 75 minus X, or we could do negative X plus 75, either way. Now I'm going to take that, substitute it into the other equation in the place of Y, and I will get 8X plus 5 times Y equals 444. It's 375. 8X plus 375 minus 5X equals 444. Subtract 8X minus 5X. That gives us 3X. Subtract 375 from both sides. And we get 3X equals 25 and 44 is what, 69, which means X equals 23. So 23 adults.
Would it be negative 23?
No, it's definitely positive.
Why is 3 negative?
What? Oh wait.
Why did I do 2?
I don't know. 8X minus 5X is positive 3X. And 444 minus 375 is positive 69. So 23 adults and
Oh, I see.
52 students.
So it's 23?
That's right.
Okay.
23 adults. And this is where it kind of becomes very important to go back to your original problem and make sure that you see where you define things, right? X is adults and Y is students. Okay? All right, homework.